Okay, dear students, once again with another interesting class for you. Here I am going to explain. Yes, which chapters? Can you guess? And it is the binomial theorem, one of the vital chapter of your class 11 math. Binomial theorem. Okay? Understand? Yes. So all of you know what is algebraic expressions and what is the different type of algebraic expression. One of the algebraic expression is known as what? All of you know binomial expression, or simply we say binomial. Binomial, trinomial, all of you know. Okay, so what is binomial? The binomial is that binomial. Yes, binomial. And algebraic expressions having two terms connected by plus or minus sign is known as binomial expression. Okay, and algebraic expressions yes, and algebraic expressions okay consist of two terms connected by plus yes, connected by plus or minus sign. Connected a plus or minus sign is known as binomial expressions. Binomial expressions, or we say binomial. Okay, and for example we can say here x plus y is an example of binomial because this algebraic expression having two terms connected by plus sign. Similarly, we can write x minus y, or a plus b, or a minus b, or x square minus x by 4. So etc. These are the example of binomial, all of you know, right? Okay, understand? Here I am discussing binomial theorem. Let us see binomial theorem. What is binomial theorem? An important theorem of the binomial. Okay, yes, expansion. So what is binomial theorem? Yes, what is binomial theorem? It is a theorem a theorem which can be used to expand a binomial to any power is called a binomial theorem. It's called a binomial theorem. Understand? So it is a theorem and which can be used to expand a binomial to any power. Okay, it's called binomial theorem. Understand or not? Okay, let us write, and we are going to write down the binomial theorem, and also you have to prove the binomial theorem by method of principle of induction. Okay, is it clear? Let's see. Okay, let's see here. So is it clear what is binomial theorem? Let us write the binomial theorem. Yes, binomial theorem. Point 1, binomial theorem. Binomial theorem is that. What is binomial theorem? Yes, it is saying that if, what is the statement I am writing first? If A and B are any real number, if A and B are any real number, yes, if A and B are any real numbers, okay, if A and B are any real numbers, then for all the natural numbers, all the natural numbers, n belongs to capital N. N belongs to capital N. Yes. Okay. And I am writing the general expression of the binomial theorem. Okay. What is the theorem? Right? And you see A plus B whole to the power N. Here I am taking the binomial theorem of the power is a positive. Okay. The power is positive integers or the natural numbers, right? And here, and the derivation is that a plus b whole to the power n. Okay, we can write nc0 a to the power n, a to the power n minus 0 b to the power 0. nc0 combination we are using, plus nc1 a to the power n minus 1 b to the power 1, plus nc2 a to the power n minus 2 b to the power 2. Okay, plus nc3 a to the power n minus 3 b to the power 3. Understand? Yes, plus up to ncr a to the power n minus r b to the power r, plus in a similar manner. Okay, and we can continue to what? ncn a to the power n minus n b to the power n. Is it clear? Yes. Understand? Look at here. Once again see. Okay, so a plus b whole, what is the statement? Let's see once again what is the statement. See what is the statement once again. Yes. And it is saying that a plus b whole to the power n, nc0 a to the power n minus 0 b to the power 0, plus nc1 a to the power n minus 1 b to the power 1, plus nc2 a to the power n minus 2 b to the power 2, plus nc3 a to the power n minus 3 b to the power 3, plus up to ncr a to the power n minus r b to the power r, plus up to ncn a to the power n minus n b to the power n. And this is the statement of the binomial theorem, right? Understand? Or we can write in such format also. Okay, we can write also a plus b whole to the power n summation of excuse me, NCR a to the power n minus r b to the power r, where r varies from 0 to what? 0 to n. 0 to n. This is the short format, and this is the expanded form, and this is the in the short format. We can write the a plus b whole to the power n is equal to summation of, okay, NCR into a to the power n minus r b to the power r, where r varies from 0 to n, right? Is it clear? And let us say carefully. And when r is equal to 0, we can write n in place of r, we can write nc0, here nc0, look at here. And a to the power n minus, in place of r we can write 0, yes or no? Yes, understand? N minus 0, b to the power 0, first term coming, you look at here. Okay, when r is equal to 0, nc in place of r we can write 0, yes, nc0, a to the power n minus 0, b to the power 0, right? Then give the plus sign. After, when r value, what are the value of r? 0, 1, 2, 3, up to dot n, up to r, up to n, understand or not? So next the value of r will be 1. When value of r will be 1, then it will be what? Next we point in nc, in place of r we have to write 1, nc1, here you see nc1, a to the power n minus 1, b to the power 1, look at here, look at here. nc1, yes, a to the power n minus 1, b to the power 1. After n is equal to 1, the value of r is equal to what? The value of r is 0, 1, then after what? 2. So when r is equal to 2, we can write nc2, ncr, in place of r we can nc2, here nc2, look at here. Okay, are you looking? Yes, a to the power n minus 2, b to the power 2. In the same process, when r is equal to r, we can write ncr, a to the power n minus r, b to the power r. And when the last term is n, when r is equal to n, we can write ncn, a to the power n minus n, b to the power n. So this is the, in the shorthand form, symbolic representation, okay, of the binomial theorem, and this is the expanded form of the binomial theorem, right? Understand? So this is one of the most important theorem where we can find out, we can expand the binomial, a binomial to any power. We can find out a plus b whole to the power 13. And all of you know a plus b whole square. This is one of the important identity expansion. A plus b whole to the power 3, yes. And similarly a plus b whole to the power 13. Okay, and here a plus b whole to the power what? 50. This type of expansion we can do, okay, and using this theorem. Is it clear? So today I am going to derive how to prove this binomial theorem by the principle of mathematical induction. Yes, let's see. Okay, understand? Okay, let us note down the statement. Let us note down the statement. Okay, write down. Okay, thank you. Let's see how to derive this. How to derive this binomial theorem. Let's write once again. So student, look at carefully, because and this is the one of the important derivation where we are going to prove the binomial theorem using the principle of mathematical induction. All of you know how to derive the statement, how to prove the statement using the mathematical principle of mathematical induction. Okay, understand? Is it clear? Okay, let us write once again. Let us write a plus b whole to the power n is equal to nc0, a to the power n minus 0, b to the power 0, nc1, a to the power n minus 1, b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, plus then nc3, a to the power n minus 3, b to the power 3. Similar manner, we can proceed nc r a to the power n minus r b to the power r plus up to ncn a to the power n minus n b to the power n. Understand? Let us prove by principle of mathematical induction. So according to principle of mathematical induction, okay, any statement we are going to prove, first of all you have to okay, and you have to take let Pn be the given statement. This is the given statement, let us give the name of the statement, let Pn be the given statement. Okay, let Pn, let us prove it. Okay, we are going to prove here. Let us write. Prove it. Okay, let Pn be the given statement. Let Pn stands for the statement. Let Pn stands for the statement. According to principle of mathematical induction, okay, let Pn stands for the statement, right? Okay, look at carefully all of you. I hope you will develop your patience to watch this class and also you will follow it. Okay, a little bit tedious to explain, okay, but look at carefully and observe. The class will be very much nice and it is interesting fact, and you will get from the derivation and how to prove this okay, this binomial statement by principle of mathematical induction. Okay, then Pn be the statement which is a plus b whole to the power n is equal to, okay, nc0 a to the power n minus 0 b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2, okay, plus nc3 a to the power n minus 3 b to the power 3. In a similar manner, ncr a to the power n minus r b to the power r, and the last term is that ncn, yes, a to the power n minus n b to the power n. Let us consider the Pn stands for the statement such that the Pn, okay, such that a plus b whole to the power n, nc0 a to the power n minus 0 b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2 plus up to nc3 a to the power n minus 3 b to the power 3 plus up to similar manner. Okay, we will continue ncr a to the power n minus r b to the power r plus up to ncn a to the power n minus n b to the power n. Okay, and according to this principle of mathematical induction, we have to prove that let p1 is true when n is equal to 1. When for n is equal to 1, let us prove p1. It means you have to prove that, okay, and when for n is equal to 1, okay, we have to prove the statement, whether the statement true or not. Okay, so before proving the statement, when for n is equal to 1, let us see LHS what? A plus b whole to the power n. Okay, and that is equal to a plus b whole to the power, in place of n we can write 1, and that is equal to a plus b. A plus b whole to the power n what? A plus b whole to the power 1, and that is a plus b. Is it clear? Then let's write RHS. In the RHS, right, what is the RHS? NC0. Here we have taken in place of n is 1. So in place of n we can write 1. NC0, n means 1C0. In place of n we can write 1. Okay. Here you see 1C0. A to the power, okay, here n minus 0. In place of n we can write 1 minus 0 b to the power 0 plus next nc1 means 1c1. In place of n we have to write 1 nc1. A to the power is 1 minus 1 and b to the power 1. Okay, understand? So again you see n1c0, and one of the important formula of combination, you know, nc0 value always 1 and n value always 1. All of you know. This is the formula. No? Yes? Yes or no? What is the formula once again? NC0 is equal to what? 1. And NCN is also equal to 1. Note down this formula. All of you know from the chapter of combination and permutation, which one of the most important vital chapter. Okay, and here using the combination in the given expressions. Is it clear? Okay, so here 1C0. Similarly, NC0 means 1C0. Okay, the value will be 1, so it will be a to the power 1 minus 0 is a, and b to the power 0 already you know 1, plus similarly 1C1 means NC1 value always 1. So that's why the value will be 1, and here a to the power 1 minus 1 is 0, a to the power 0, and which is 1, and b to the power 1 means b. Okay, understand or not? Hence we see the LHS is a plus b, and you see RHS is a plus b. That implies LHS is equal to RHS. Hence the statement P1 is true. The statement P1 is true for n is equal to 1. So when for n is equal to 1, the statement is true. Is it clear? Understand? Okay. Is it clear? Once again see, for n is equal to 1, P of 1, whether it is true or false we have to see. Here you said LHS, and here LHS a plus b whole to the power n. A plus b whole to the power n means a plus b, in place of n we can write 1, which is a plus b. And this right hand side RHS, you see RHS, what is the RHS? You see NC0, a to the power n minus 0. In place of n we can write 1, 1C1, a to the power 1 minus 0 into b to the power 0, plus NC1 means 1C1, a to the power 1 minus 1, b to the power 1. And 1C1 value what? 1. And a to the power 1 minus 0, a to the power 1, which is a. And b to the power 0 value 1. Yes. Similarly, one C1 value always 1. Yes. Is it clear? So a to the power 1 minus 1 means a to the power 0 value, a to the power 0 value 1, and here b to the power 1 is b. That's why it is a plus b. Here LHS is a plus b, RHS is a plus b. Hence LHS is equal to RHS. Thus for n is equal to 1, P1 is true for the statement. And according to the mathematical principle of induction, all of you know, if P1 is true, then P2 also, for n is equal to 2, P2 is also true. And similarly, we can verify. Similarly, for n is equal to 3, the P3, the statement P3 is true, must be true. Similarly, for you see n is equal to k, so the pk is also true. Pk is also true. All of you know how to prove the statement using the principle of mathematical induction. So pk is true. Understand? So the statement pk is true. Look at here. It means the pk is true. Let us note down here. Is it clear? Okay, let's see. Shall I proceed? Okay, let's see now. So it is a long derivation, students, so you have to develop patience to listen here, and this is one of the most important learning point for you also, how to prove the binomial theorem using principle of mathematical induction. Thus pk is true for n is equal to k. It means we can write pk, statement pk, a plus b whole to the power k is equal to a to the power, yes, it is nc0. Here is kc0, we can write, you write kc0, here the power is becoming k, so kc0, a to the power k minus 0, b to the power 0, yes, plus kc1, a to the power k minus 1, b to the power 1, plus kc2, a to the power k minus 2, b to the power 2. Similarly, if we proceed, okay, and it will be kc. We can write also kc3 a to the power k minus 3 v to the power 3, right? Understand? And in the same process, if you proceed here, and it will be kcr a to the power k minus r and v to the power r, and up when similarly kck, yes, a to the power k minus k b to the power k. Understand? Okay, we have to. So the statement, since pk is true, first of all p1 is true. If p1 is true, pk is also true. We have to prove that pk plus 1 is true when n is equal to. We have to prove for, okay, we have to prove that we have to prove that for n is equal to k plus 1. If you can prove for n is equal to k plus 1, then pk1 statement, pk plus 1, we have to prove this true. It means we have to prove that, yes, a plus b whole to the power what? K plus 1, which is k plus 1 c0. Yes or no? Here power is being k plus 1, which is a to the power k plus 1 minus 0 b to the power 0. Yes. Understand? Okay. Then here the power is coming what? K plus 1. Here you see plus k plus 1 c1 a to the power k plus 1 minus 1. K plus 1 minus 1, what is the value? It will be k. Yes or no? And b to the power k plus 1 minus 1, b to the power what? 1. Yes. Similarly, plus, okay, k plus 1 c2 a to the power k plus 1 minus 2 and b to the power 2. Yes. Plus k plus 1 c3 a to the power k plus 1 minus 3 b to the power 3. In the same process, okay, it will be what? It will be kcr. It will be, the power is k plus 1 cr a to the power k plus 1 minus r and b to the power r in the same manner, and it will be k plus 1 c k plus 1 and a to the power 0 and b to the power k plus 1. Okay, and for n is equal to k plus 1, a plus b whole to the power k plus 1, which is k plus 1 c0 a to the power k plus 1 minus 0 b to the power 0 plus k plus 1 c1 a to the power k plus 1 minus 1 b to the power 1 plus k plus 1 c2 a to the power k plus 1 minus 2 b to the power 2. In the similar manner, okay, you can prove up to k plus 1 c k plus 1 a to the power 0 b to the power k plus 1. So, okay, so in order to prove, this is one of the vital statement. This line is the vital line. Okay, you have to prove that, and if you can prove for n is equal to k plus 1, the pk plus 1 is true, then the statement is true as per the principle of mathematical induction, right? Understand? It means we have to prove that a plus b whole to the power k plus 1, this statement we have to prove. We have to prove that for n is equal to k plus 1, pk plus 1 will be true. Understand? Is it clear? Okay, and this line, if you can prove this line is true, then the given statement will prove. Okay, let's see how to prove pk plus 1 is true. This is one of the lengthy concept, okay, but, and you need to develop the patience, being science student, all of you. Okay, understand? Yes. Okay, let us note down here. Okay, understand? Okay, let us prove this one. What to prove here? Yes, we have to prove that pk plus 1 is true. It means pk plus 1, once again I am writing, is pk plus 1. The statement is that a plus b whole to the power k plus 1 is equal to k plus 1 c 0 and a to the power k plus 1. You see, this is a to the power k plus 1, b to the power 0 means what? 1 plus k plus 1 c1, a to the power, look at here, k plus 1 minus 1, cancel, it will be what? K, and here b to the power 1. Understand? Okay, understand? Okay, and plus k plus 1 c2, a to the power k plus 1 minus 2, plus 1 minus 2, k plus 1 minus 2, which is k minus 1, which is k minus 1, k minus 1 is, and b to the power 2. Okay, is it clear? Similarly, k plus 1 c3, yes, a to the power, you see, k to the power 1 minus 3 is k minus 2 into b to the power what? 3. Similar process we can write, okay, k plus 1 cr, okay, a to the power k plus 1 minus r, or we can write k plus 1 minus r, b to the power what? R. Is it clear? Plus up to, yes, k plus 1 c k plus 1 a to the power b to the power k plus 1, and this statement we have to prove it. And if you can prove this statement, then the statement of binomial theorem is already proved, right? Okay, let's see how to prove this one. Yes, understand? Here, see carefully. Whenever proving a statement, you have to prove LHS to RHS. If you see a plus b whole to the power k plus 1, let's see first. Let us write on LHS, left hand side. Yes, let us write LHS. LHS side. Okay, let us write a plus b whole to the power k plus 1. Yes, and here all of you know a plus b whole to the power what? Into a plus b whole to the power k. So a plus b k to the power k plus 1, which is a plus b whole into a plus b whole to the power k. Now a plus b, and here a plus b whole to the power k, you can use the binomial theorem, what? Kc0, a to the power k minus 0, b to the power 0. Understand? Plus after that what? Kc1, a to the power k minus 1, b to the power 1, plus kc2, a to the power k minus 2, b to the power 2, right? Okay, plus similar manner kcr, a to the power k minus r, b to the power r, up to kck, okay, a to the power k minus k, b to the power k. Okay, understand? Is it clear? Okay, okay, now let's see. Let us multiply a plus b into the first term kc0, a to the power k minus 0, b to the power 0. Let us multiply here. Can you multiply a whole into kc0, okay, a into a to the power k minus 0, a to the power k, here a to the power k minus 0 means k, here k to the power 1, it will be k plus 1, and b to the power what? 0. Let us see. A to the power 1 into a to the power k plus, according to laws of exponent. Similarly, yes, here b is multiplied here, plus kc0. Similar manner we can write a to the power k, b to the power what? Here power is 1, here power is 0, 1 plus 0 is 1. Understand? So here multiplied a plus is multiplied with the first term. Similarly, a plus b is multiplied with the second term. First to multiply a is multiplied with the kc1, a to the power k minus 1, b to the power 1. Let us see. Plus kc1, plus kc1 a to the power, here k minus 1 plus 1, it is k minus 1 what? K. And b to the power, you see, b to the power what? Here kc1, a is multiplied with kc, a to the power k minus 1. Okay, k minus 1, here power is 1. It will be what? Are you understanding or not? Let us see, this is a to the power k minus 1 into a to the power 1, and it will be a to the power k minus 1 plus 1, which is a to the power k. Is it clear? So a to the power k I have written, b to the power 1 I have tried. Similarly, again b is multiplied with kc1 plus, note down carefully, look at, again you see kc1, okay, a to the power k minus 1 and b to the power 2, because here power of 1 is, b is 1, here power is 1, so b to the power 1, here 1 plus 1, it will be 2. Very simple according to laws of exponent. Right? Okay, let us see kc0 a to the power k plus 1 b to the power 0, kc0 a to the power k b to the power 1, kc1 a to the power k b to the power b, and kc1 a to the power k minus 1. Similarly, multiply a plus b into kc2. So plus kc2 is a to the power k minus 2. Here power is a. What is the power of a here? What is the power of a? K minus 2. And here power is 1. So k minus 2 minus 1 is k minus 1 and b to the power 2 plus kc2. Again this b is multiplied with this term. kc2 a to the power k minus 2 and b to the power what? B to the power 3. Is it clear? Understand? In the same process, if you multiply here, look at here, okay, and here you have to multiply what? A is multiplied kcr a to the power k minus r plus 1 b to the power r plus kcr a to the power k minus r b to the power r plus 1. Right? Here power of b is 1, so here power of b is okay. And similar manner, what is the last term? K C K. Okay, understand? Here a to the power what? K minus k means what? 0 we can write also 0. So a to the power what? Okay, here power of a is 1, here power of a is 0. So 0 plus 1, it will be 1. Okay, into b to the power k plus k c k. Yes, okay, a to the power 0 or a to the power 0 1, you can discard b to the power k plus 1. Here a to the power 0 is 1 also, so 1 is the multiplicative identity, so you can discard. Understand or not? Is it clear? Little bit it is, you might be feeling this is very okay, because whenever you are proving the expansion by the method of induction little bit, and you have to derive the expression in careful manner. Understand? Is it clear? Okay. Understand? See this line, note down this line, note down. Okay, understand? Okay, so I clean this part I am cleaning this part. Look at here, once again see, you see here kc0 a to the power k plus 1, here b to the power 0 means 1, okay, plus once again say a to the kc0 a to the power k b to the power 1 plus kc1 a to the power k b to the power 1. Can you bring a to the power k here, b to the power 1, a to the power k b to the power 1 is a common factor. Once again say carefully, look at here Here you see a to the power k b to the power 1. Here a to the power k b to the power 1 is a common factor. If I bring the common factor, then it will be kc0 plus kc1 a to the power k b to the power 1. A to the power k b to the power 1. Understand? Is it clear? In the similar manner, look at next two terms you see. kc1, this term and this term you see. Look at here. Here you see. Here a to the power k minus 1 is a factor and b square is a factor. Yes. And here a to the power k minus 1 b square is a factor. So it is a common factor we can bring. Okay. So write down here. Here you get kc1 plus kc2 and it will be a to the power k minus 1 b to the power 2, right? Understand? B to the power 2, right? Are you getting my point? Okay. And here you see, here this is, and this term I brought the common factor. Here you see a to the power k minus 1 b square. Here a to the power k minus 1 b square is a common factor. So I can bring as a common factor, after bringing that, it will be kc1 plus kc2 a to the power k minus 1 b square. Okay. Okay. And next two terms, similar process we can write. Look at your pattern. We are getting a pattern here. You see, kc0, kc1 a to the power k b to the power 1. Are you looking something else? Yes. kc1 plus kc2 a to the power k minus 2 k minus 1 b to the power 2. Are you looking here? When here's okay, here the value is r is equal to 1, here power is 1. When r is equal to 2, here power is 2. It means this is one more. Is it really? If you compare this one, this will be 1 and this will be 2 power. Similar manner, next term, I think you are able to understand. Look at carefully. Okay. Plus we can write in the next step kc what? 2. See kc0, kc1. Again kc1, kc2. Next kc2 plus it will what? kc3. Yes or no? And a to the power. You see here a to the power k minus 1. Here 1. So here a to the power what? K minus 2. And here b to the power what? Here you see this value is 2 and this value is also 2. K to the power 3. This substitute 3 here 3 here 3. Yes or no? Similarly you can write next term kc3 plus kc4 a to the power what? K minus 3 b to the power 4. I hope you will understand this one. kc3 plus kc4 whole into a to the power k minus 3. Here 3, here also 3, here 4, here 4. Once again see, here look at here. Here 1, here 1. Here power 2, here also 2. Are you comparing? Okay. Here 2, here also 2, power 2. Here 3, here 3. Similarly, if it is 3, it is also 3. If it is 4, it is also 4. It is coming into a pattern. Are you getting my point? Is it clear? Similar manner, can you say same process like that? You can say last, you can say also what you can say. Yes. Yes. Similar last term will be what? K C K b to the power k b to the power k plus 1. You will get the last term also. Okay. So this line is clear. Yes. Okay. According to the condition, one of the important properties of the combination. What is the properties of combination? All of you know. We know NCR. One formula write down. NCR plus NCR minus 1 is equal to N plus 1 CR. Okay. And all of you know NCR plus NCR minus 1 is equal to, it will be N plus 1 CR. This is one of the important properties already. Yes. Okay. I will derive this one. Already you know. Once again, if you have doubt, I will, okay, and will prove it in the next class. You can see. Now look at here. What are you looking here? See. I think. Yes. You see now KC0. Now KC0. KC0 value also 1. We can write K plus 1, C0 also 1. And again KCK also 1. This value is 1. Also K plus 1, CK plus 1 is also 1. Okay. So you can write K in place of KC0, you can write K plus 1, C0. The value will be 1. Not a problem here. And a to the power K plus 1 plus KC0 plus KC1. We can write K plus 1 CR, a to the power K, b to the power 1. Look at here, first one you see, K plus 1 C0, a to the power K plus 1, a to the power K plus 1. Coming or not? Coming first term. And similarly, second point you see, K plus 1 C1, a to the power K, b to the power 1. Here K plus 1 C, here it will be 1 in place of R, you write 1. So a to the power K, b to the power 1, right? Understand? Similarly, K plus 1 C2, I can write a to the power what? Next term you write, yes, KC1 plus KC2, I can write K plus 1 C2, a to the power what? A to the power, yes, it will be K minus 1. Here the power of K will be decreased by 1 and the power of B will be increased by 1. 1 plus 1, 2. According to binomial theorem, here K power 1, K power is decreased, K minus 1. And here B power 1, here B power is 2. And every case you will see the degree of the every term is constant. You will see the power of A is K, here power of B is 1. So what is the degree? K plus 1. Similarly, power of A is K minus 1. Here power of B is what? What is the power of B? 2. So K minus 1 plus 2 is also K minus 1. So this is also maintained. This is one of the important factor of the binomial theorem. The degree of every term is always constant, right? Okay. So similar manner we can write plus K plus 1 C3, a to the power, here power is K minus 1, again it will be decreased by K minus 2, and B to the power what? It will be what? 3. KC3 means. And similar manner we can write K plus 1 C K plus 1. Look at last term. Last term is what? KCK. And KCK, the value is 1. And K plus 1 CK plus 1 is also 1. Understand? So it will be B to the power K plus 1. And look at this statement and this statement. Let's see. Let us compare what we are going to prove. Let us compare it is coming or not. You see KC0, K plus 1 C0, a to the power K plus 1. K plus 1 C0, a to the power K plus 1. Next, K plus 1 C1, here K plus 1 C1. A to the power K, B to the power 1, a to the power K, B to the power 1. And the next term is K plus 1 C2, here K plus 1 C2. Here a to the power K minus 1 B square, a to the power K minus 1 B square. Here you see K plus 1 C3, here also K plus 1 C3. And a to the power K minus 2 BQ, here also a to the power minus 2 BQ, right? And the last term is K plus 1 CK plus 1 B to the power K plus 1. It means we are getting this is equal to RHS. Hence we prove LHS is equal to RHS. So according to principle of mathematical induction, the statement is okay for n is equal to K plus 1, the statement is true. Hence for K is equal to, for n is equal to K plus 1, yes, so P K plus 1 is also true. Understand? Okay. So that is the very vital principle of mathematical induction. Is one of the very important statement, how to verify, prove the statement. Okay. This is how we can verify, since for k is n is equal to k plus 1 and pk plus 1 is true, so the given statement is true. So the given statement is true. Is it clear? Thus our binomial theorem is proved and verified, right? Understand? Is it clear now? Thus we get since pk plus 1 is true, since pk plus 1 is true, yes, since pk plus 1 is true for n is equal to k plus 1, pk plus 1 is true. So thus it is proved that Pn or a plus b whole to the power n, which is nc0 a to the power n minus 0 b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2. In the similar manner, ncn a to the power n minus n b to the power n, or a short form we can write the summation of a to the power summation of ncr a to the power n minus r b to the power r, where r varies from 0 to 1, 0 to n. This is how the given statement, the binomial theorem, is proved. Okay students, this is one of the most important theorem, and here we already proved using the concept of principle of mathematical induction, and this is the formula, note down. And with the help of this binomial theorem, we can find out, we can expand any binomial to any power, Is it clear? Understand? I hope you will understand it and you will practice it. Let us practice it. Okay. The concept is most important factor of mathematics. Understand or not? And you should need to develop patience among you. Okay. And let us follow this class. Okay. And also practice this. Next, this is the one of the introductory class. And in this class, I explain the concept and the theorem of the binomial theorem. Okay. Next class we shall discuss about the properties of the binomial theorem. Understand? I hope you will follow and practice. Okay, thank you. See you all of you. Thank you. See you next